Hello everyone, today our topic is Entity Relationship Model or ER model. A database contains entities and relationship among the entities. An entity is an object that exists and is distinguishable from other objects. For example, student, department. Entities have attributes. Attributes means a set of features, the properties an entity can have. For example, a student has student ID, student name, student roll number. So these are all attributes of the student. An entity set is a set of entities of the same type that share the same properties. If you consider a number of students, then it can generate an entity set that contains the student entities which share the same attributes or same properties. A student is an entity set. If you have a number of students, then student can have student ID, student name, student department, email ID. So these are all attributes of student. An entity is represented by a set of attributes, as I have mentioned previously. Now, what is a domain? Domain is a set of permitted values for each attribute. For example, if I say that student ID cannot be null, or if I consider another attribute, for example, marks, and marks cannot be greater than 100%. So, it should be less than or equals to 100. So then that is the domain of that particular attribute. Now, attribute types. Attribute can be simple, can be composite, can be single valued, can be multi-valued attributes, can be there are derived attributes also. I will explain all these things later. Now, first is relationship set. A relationship is an association among several entities. A relationship set is a mathematical relation among n greater than equals to two entities. Whenever you are considering more than one entities, then that there can be an association, there can be a relation. So that's why n greater than 2. Okay, each taken from entity sets. Here in this particular one, in this slide you can see e1 e2 en. So this e1 e2 en, this is a relationship. So while e1 belongs to capital e1, e2 belongs to capital e2. Okay, degree of a relation refers to number of entities that participate in a relationship set, and that is the degree of the relation. Now, what is an entity relationship diagram? If you pictorially represent the entities and the relationship among those entities, then it will create an entity relation. It will be an entity relationship diagram. Now, in that case, as you are considering a diagram, so there should be some symbols. So here, a rectangles represent the entity sets, diamond represents relationship sets, lines links attributes to entity sets and entity sets to relationship sets. Ellipses represents attributes of the attributes of the entity. Double ellipses represents multi-valued attributes. Dashed ellipses denote derived attributes. Underline indicates primary attributes. So ellipses represent the attributes of the entities. So these are the notations, the symbols rather I can say. Now what is cardinality? Cardinality presents the number of entities to which another entity can be associated via relationship set. For a binary relationship, as I am considering, when association can possibly number of entities or entity set is more than one. So usually whenever you are considering the relationship among entities, then usually we consider relationship among two entities, between two entities rather, as I am considering two. So between two entities, okay. So then I can say it's a binary relationship. So binary relationship say the mapping cardinality must be one of the following types. What are those types? One to one, one to many to one, many to many. Now here you can see is an entity set. B is another entity set. Okay. A1, A2, A3, A4, the entities of A. B1, B2, B3, B4 entities of B. A1 is associated with B1, A2 is associated with B2, A3 is associated with B3, A4 is associated with B4. That means all these things are what it is representing, that is one to one. Now in the second picture you can see here A1 is associated with B1 and B2. A2 is associated with B3 and B4. A3 is associated with B5. Then what you can say, this is one to many. Many to one. Here you can see A1, A2 is associated with B1, A3 is associated with B2, A4, A5 is associated with B3. Then this is the many to one relation. Many to many. A1 is associated with B1 as well as B2. A2 is associated with B1. A3 is associated with B3 as well as B4. A4 is associated with B3. Then this is actually many to many relationship. So these are the different cardinality types. Now you can represent this cardinality using these notations also. Here many to many relationship. In this way you can represent one to one. Both sides there will be one. R means the relationship set. Okay. Many to one relationship. Many you are denoting using star. Or right inside you can another picture is you can see that different type of representations are there. It's an alternative notations. Represent the cardinality. Now, what is the super key? Now, before going to the interrelationship diagram, let us first consider what let us um, first tell you something about keys. Let me tell you something about keys. Now, what is a key? I have mentioned in previously that primary key attributes is if you consider the primary key, then that will be underlined. Okay. So now, what is a key actually? Now, before going to primary key, first let us understand what is super key. A super key of an entity set is a set of one or more attributes whose values uniquely determine each entity. For example, if you consider student ID, student name. In student ID, student name, if you consider both these two entities, then you can determine each entity uniquely based on the values of these two attributes. Okay, so then that can be a super key. Now, can if you consider a minimal super key, for example, if I consider student ID only, then also I can uniquely determine other attributes also. Determine each entity. We can using ID, it can uniquely determine each entity. Then it is a minimal super key. Then I can say this is a candidate key. So candidate key of an entity set is nothing but a minimal super key. For example, if I consider a customer entity, then customer ID can be a candidate key of customer. Account number, if I consider another entity set account, then account number is a candidate key of account. Although several candidate keys may exist, one of the candidate keys is selected to be the primary key. The combination of primary keys of the participating entity sets form a super key of a relationship set. For example, if you consider customer ID and account number, both, then it can be a super key of another entity set deposit. A pair of entity set that can have at most one relationship in a particular relationship set. To track all access dates to each account by each customer, you cannot assume a relationship for each access. Now, this is an entity relationship diagram. Here, customer is an entity, loan is another entity, and relationship is borrower. Okay. So, customer name, customer street, customer city, customer ID are the attributes of the entity set customer, entity customer. Okay, customer ID is the primary key of this entity set. So, that's why it is underlined. You can see here the attributes are represented by ellipses. Now, loan, it has two attributes, amount and loan number. Loan number is the primary key of the loan entity set. Now, here, customer is an entity. Customer has this all this name. Here you can see this name. Name actually is a composite attribute, because if you decompose it into it can decompose it into three parts: first name, middle initial, and last name. So then name is a composite attribute. Here age is a derived attribute. You can see date of birth. Date of birth. From the date of birth you can calculate the age of the customer. Now date of birth is one attribute, and age can be calculated based on date of birth. Then age is, if you consider age another attribute, then age is a derived attribute. So that's why it is represented by dotted ellipse. Now phone number. Our customer can have multiple phone numbers. So then that is represented by this double ellipse, because it's a multi-valued attribute. A customer has an address. Address is an attribute of the customer. Now this address can be again decomposed into street, city, state, zip. Street again decomposed into street number, street name, apartment number. So this address is also a composite attribute. Now here you can see this employee works for manager. Employee can be worker, employee can be manager. Okay, so an employee is an, if you consider employee as an entity set, then employee ID is the primary key. So that's why it is underlined. Employee name and telephone number are other attributes of the entity set employee. So here the labels manager and worker are called roles. They specify how employee entities interact via works for relationship. Works for is a relationship set. Roles are indicated in ER diagram by labeling the lines that connect diamonds to rectangles. Now here you can see there's another way of representing cardinality, 1 to 1. A customer can have one loan if I consider in this way, then 1 to 1 relationship. If you consider that a customer can have more than one loan, yeah, can have, then 1 to many relationship. Many to 1. A customer can have more than one loan, loan more than one customers take loan. Then so this both sides is possible, many to one as well as one to many, both are possible. Next is many to many. A customer can have more than one loan. Loan, more than one customers can take loan. Customer, so then I can generate a many to many relation. I can consider a many to many relationship. So cardinality. So then it can be represented by in this way. Now, how you can represent this total participation? Total participation is represented by double line. Every entity in the entity set participates in at least one relationship in the relationship set. Now, what is a weak entity? Weak entity set that does not have a primary key, then that is represented as weak entity set. Existence of a weak entity set depends on the existence of identifying entity set. It must relate to the identifying entity set via total one to many relationship set from the identifying the to the weak entity set. Identifying relationship depicted using a double line. For example, here you can see payment is a weak entity set. Payment does not have a primary key. Now, whenever you are considering, then payment along with payment number, you have to consider loan number also. For the primary key of payment, loan number, comma payment number. So payment number is a discriminator of the payment entity set. If you consider loan number as well as payment number, then you are getting this primary key. They had loan is the identifying entity set. Okay. Now what is specialization? Specialization is a top-down design process designates subgroupings with an entity set distinctive from other entities in the set. These subgroupings become lower level entities depicted by triangle component labeled ISA. ISA actually ISA. Okay. Lower level entity set inherits all the attributes and relationship participation of the respective higher level entities. I will take an example, then it will be much more clear. Here you can see employee and customer. Both are two entity set. Employee has salary, customer has credit rating. Both comes under person. If you consider person as an entity set, then an employee is a person as well as customer is a person. Okay, then that is you are specializing person into two parts. One is employee, another is customer. You are just specializing person entity set into two lower level entities, two lower level entity set, employee and customer. Now employee can again be officer, can be tailor, can be secretary. So then employee, you are again subgrouping employee into three lower level entities. What are the lower level entities? Officer, tailor and secretary. So that means you are designating subgroupings with an entity set distinctive from other entity set. Subgroupings become lower level entity set. You are just breaking it into decomposing actually. So here office number is the attribute of officer. The station number, hours worked are the attributes of tailor. Hours worked is the attribute of secretary. So employee is a officer, is employee can be a tailor, can be a secretary. So they were specializing employee into again officer, tailor and secretary. Now generalization is an opposite, just inverse of specialization. This is a bottom-up design process. Here you are combining number of entity sets share the same features into high level entity set. Specialization generation is simple inversions of each other. They represented in an ER diagram the same way that terms specialization generation are used interchangeably. You can see here if you consider this Officer, tailor, secretary, both are under employee. So employee is a generalized form. So again, employee and customer both comes under person. So person is a generalized form. Now what is aggregation? The process by which entities are combined to form a single meaningful entity is the process aggregation. So you can see job, employee, branch, these are entities. Now employee works on branch, employee works on job. Employee manages branch. Employee manages job. Manager manages branch. Manager manages employee. Manager manages job. So now you can consider this job, employee, branch works on all this together. So you are combining all this. So manager manages all these three. So you can combine them. So that is actually aggregation. So manager manages branch, manager manages employee, manager manages job. Okay, so you are combining this all. So this is the process aggregation. So thank you. In my next class, I will discuss on relational algebra.